Hi everyone, Professor Sarah back here with the next section of our Batiquitos Lagoon virtual field trip and oceanography lab exercise. In this section, we'll be looking at some of the geological processes that formed Batiquitos Lagoon. Over Earth's history, there have been many cycles of natural climate change, mostly caused by small variations in the Earth's orbit and rotation. For example, perhaps you've heard of the terms like Ice Age, or maybe you've read that the Earth was warmer during the time of the dinosaurs. In fact, it was so warm during the Cretaceous period, some 90 million years ago, that dinosaurs lived in lush rainforests, even in polar regions that are today covered with ice, like Antarctica. You will learn more about these causes of long-term natural climate cycling later on in the lecture portion of this class, as well as the causes of the rapidly developing human-caused climate change issues our planet is facing today. For this lab, however, we want to address how natural climate cycles over the past 20,000 years or so helped create and shape our local Southern California coastline and its coastal estuaries and lagoons. In discussing some of these climate variations, we can refer to these long periods of thousands of years as glacial periods and interglacial periods. Glacial periods are periods of time that are marked by colder temperatures and increased ice formation and glacial advances. As an example, the figure here shows the approximate extent of Earth's ice cover today, which you can see at the South Pole on the left and at the North Pole on the right. During a previous glacial period, however, you can see just how much more ice coverage there was. During these colder glacial periods, more ice forms, effectively stealing liquid water from the oceans and locking it up in all of this additional ice coverage. Therefore, during glacial periods, the sea level drops, and sometimes very dramatically, as we'll see in a moment. In between these glacial periods are interglacial periods, which are periods marked by warmer climate that occur between the glacial periods. During warmer interglacial periods, ice melts into liquid water, which then flows into the ocean, causing the sea level to rise. Earth is currently in an interglacial period called the Holocene epoch, and sea level stands at the levels you can see in this map image. Human-driven climate change will force sea levels to rise, and more land will be covered by water in the future. During the last glacial period, however, sea level was at least 120 meters, or almost 400 feet lower than it is today, exposing much more area on the continents. Let's rewind the clock and visualize what that would look like. These changes in sea level, driven by changes in climate, have directly affected the shape and structure of coastal features around the world. Before we dive further into the reasons why that is, we have one more concept to cover. Let's briefly discuss how canyons are carved by rivers, using a very dramatic example, the Grand Canyon in Arizona. The rock layers in this area were forced upward via tectonic forces, and several million years ago, the Colorado River began to flow across these uplifted rock layers. The force of that running water cut into the rock layers of the Colorado Plateau as it flowed, chipping away rocky bits called sediments and sweeping them away in a process called erosion. Over time, it carved the very famous steep-sided canyon we now call the Grand Canyon. This is, of course, an extreme example, but similar processes are at play here in Southern California. Southern California has a rich tectonic history that could easily fill its own video, but this animation does a good job in providing a visual of some of its more recent geologic history over the past few million years. Compressional squishing of the rock together shortened and uplifted the rocks of Southern California, literally moving the land higher above sea level than it was before. Rivers then cut into these uplifted rocks as water flowed downhill and out to sea. In this photo, taken from a helicopter overlooking Camp Pendleton, you can see some small examples of where flowing water cut into rocks on its way out to the Pacific Ocean. You can also see the coastal cliffs on either side of the canyon, remnants of that uplifting of rock. The flat tops on the cliff were once at sea level in the past and flattened by wave activity, but later lifted up by those tectonic forces. Now, if sea level were to rise, what area of this photo would fill up with water first, do you think? Let's look into that idea further. To better understand the role that sea level changes have had in shaping the Southern California coast, including Batiquitos Lagoon, over the past 20,000 years or so, We will utilize some excellent paleocoastline modeling figures and descriptions provided by the Coastal Morphology Group at Scripps Institution of Oceanography. The initial appearance of sand beaches is a crucial turning point in the recent evolution of the Southern California coast. Sea level has changed dramatically during the last 20,000 years from a glacial low stand, or a lower sea level, to its present interglacial high level, or higher sea level. We'll use the following diagrams to further explore the history of the Southern California coastline. Stage 1. Sand beaches usually form at high sea stands, or high sea levels, and the last interglacial high stand 125,000 years ago brought wide, long-lasting sand beaches to the Southern California coast. As we learned earlier, the sea level was much lower during glacial periods when ocean water became locked up in additional ice cover. So how might that affect the coastlines? Let's explore that scenario further. During the last glacial period around 20,000 years ago, sea level stood about 120 meters or nearly 400 feet below the present sea level. Here in stage 2, you can see that much more land is exposed that was previously underwater. Streams cut deep valleys as they crossed the exposed shelf. The power of streams to transport erosion materials was increased by the steeper gradient between the mountainous watersheds and the lowered sea level. Stage 3. During this time, with a much lower sea level, coarse materials like cobbles and boulders were washed to the coast, and the deltas formed by these materials were gradually dispersed by waves and currents to build cobble beaches along the coastline. Now, as we learned earlier, glacial periods with low sea levels are broken up by warmer interglacial periods, which will prompt sea level rise. So what might that look like? Stage 4. As the glaciers melted and sea level rose rapidly, rocky coasts were submerged, covered by water, and estuaries expanded and flooded up those newly carved stream valleys. Estuarine habitats of the early Holocene, around 11,000 to 8,000 years ago, were rich environments teeming with fish, birds, and shellfish. Sediments were now deposited in the heads of these embayments, leaving the open coast with cobbles and rocky intertidal habitats. Stage 5. When sea level rise slowed down around 8,000 to 6,000 years ago, waves began cutting the present shore platform, and sediment brought to the coast during floods formed the first sand beaches. The estuaries became tidally flush lagoons with sand and mud flats. Rocky intertidal and shallow reef habitats were buried by sand as modern beach compartments and sedimentation cycles became established. Today, if you were to look eastward and up Batiquitos Lagoon, inland, you can see how these geological processes played out in carving this estuary. What is underwater here used to be a river canyon where water drained from inland sources out to an ocean that was much further offshore than it is today, thanks to the sea level being nearly 400 feet lower during the last glacial period. As the earth warmed up again and ice melted, sea levels rose again, and the water backed up, flooding what is now Batiquitos Lagoon and moving the beach further inland. I hope you've enjoyed learning more about how climate influences sea level and how changes in sea level have shaped Southern California's coastline and coastal estuaries. This is Professor Beck signing off, and I'll see you in the next video.